In this video, I've got more tips and tricks for Tekla Structures. Hello and welcome to CS Wilson Draws. I'm CS Wilson. If you're looking for tutorials and information about Tekla Structures and computer-related things, then you found it. You're here. That's what we do. And you've picked a good one. More tips and tricks. Can you believe it? And honestly, I feel like I'm really just getting started. I mean, there's so many commands and settings and advanced settings and settings inside of settings and little techniques and methods that we've come up with to manipulate the software to do what we want. It's an almost endless source of content, at least from my perspective. And a shout out to all of those who've contributed to the comment section below each video with their own tips and techniques. Not to mention those who've contacted me through social media to share their own experiences. Which reminds me, if you didn't already know, you can also find me on Instagram and Twitter and Facebook and Vero as CS Wilson Draws. That's really where I share all the news and behind the scenes stuff about the channel. Admittedly, I probably post more on social media than I do here. Or at least I should say more frequently. Anyway, enough about that. You've come for the Tekla tips and tricks, so we're getting started right now. So we all use the model dimensions to check the accuracy of our models, but you can also set the accuracy of the model dimensions as well. And the way to do this differs depending on which measuring system you're using. If you use US imperial fractions, then set the accuracy by using the advanced option XS Max Fractions in Model Dimension. You can find this in the advanced options under imperial units. The number you set here will be the denominator of the fraction, such as 8, 16, 32, 64, 128, 256. I normally set mine to 32 since I want to display the dimensions down to the nearest 32nd of an inch. You'll have to reload the model in order for the setting to take effect. If you use decimals of a foot or decimals of an inch or use metric dimensions, the accuracy is set by opening the File menu, click on Settings, and select Options. From here, select Unit and Decimals and adjust the unit length and number of decimals. You can also set the angle accuracy here as well for all the measuring systems. Keep in mind, these settings only affect the rounding for your measurements and not the actual measurement distance itself. For example, if I measure between 2 points and that distance is actually 19/32, but my max fraction model dimension is set to 16, then the display distance will be 5/8 inch due to the rounding. That's why I normally set my max fraction model dimension to 32. That's really as accurate as I need to be. In Tekla Structures version 2016i and up, there's a new feature that allows you to create a bent plate from 2 plates. I won't go too much into it, but basically you start the command, select 2 plates, and a bent plate is created. A problem I've found is that the newly created bent plate is missing tabs for some of the user-defined attributes that were originally available when the parts were contour plates. Namely, the UDAs found in Notes, Assembly Status, Material Status, Orientation, and IFC Export aren't present in the bent plate properties. I don't know if this was intentional or just an oversight, but I found a couple of ways around it. Firstly, you can set the UDAs before you create the bent plate while they're still contour plates, and those settings will carry over to the new bent plate. Secondly, you can edit the UDAs after the bent plate has been created by holding Shift and activating the contour plate command. This will open the plate properties dialog. You can then cancel the command since we really don't need it active, we just need the properties dialog. Then select the bent plate you want to edit. Back at the properties dialog, uncheck all of the settings, then open the user-defined attributes. Uncheck all of these settings, just to be on the safe side, and set any of the UDAs you need to. When you're done, click Modify. This will transfer the information to the bent plate entity, as you can see here when I inquire the part properties. Something else that I recently ran across that would have been nice to know about earlier is the ability to undock the status bar message area. For those who don't know what that is, it's the area at the bottom of the screen that displays prompts for whichever command you're currently using, as well as some other information. Yeah, I know, I always thought that was called the command line. But anyway, you can undock that by going to the quick launch and typing message panel. Then put a check in the Toggle Message Panel option. Here you can see a list of the most recent messages, log file, numbering history, drawing history, and some miscellaneous info. You can also resize it, and if you have multiple monitors, you can even move it to another screen. Also, the size and position are persistent between sessions. So when you exit and reload Tekla Structures, the message panel will appear in the same place you had it last time. Now, for everyday use, I don't necessarily want the message panel open all of the time. So to make it even more practical, I've assigned the toggle to a keyboard shortcut so I can open the full panel when I need it and dock it when I don't. To find the command in the keyboard shortcuts, search for Toggle Message Panel. This next tip involves the drawing editor and shows how the datum level mark in the view settings works with the level mark command. To start with, here in the model, you can see that the bottom of the columns are at the 0 level, and looking at the grid properties, the 0 level is actually at the z-coordinate 0 as well. In the real world, the bottom of the columns is actually at elevation 113 foot 4 and a 16th, and that's what I want to display on the drawings. This is the same view we were just looking at in the model, except now we're on the general arrangement drawing in the drawing editor. I'll put a level mark at the bottom of this column and one at the top of grading. I do that by snapping to the dimension line and then extending them out a little bit. Next, I'll open the View Properties and click on the Attributes To tab. The datum level of this view is set to 0, which means the 0 level in the model has no offset. If I change the datum level to 3 foot 4 and 15/16, you'll notice that the upper elevation now reads 0 and the lower elevation now reads minus 3 foot 4 and 15/16. This is because we've just offset the 0 level in the model in the positive direction, or up, on the z-axis. This is fine and kind of fun to play with, but remember, I want the bottom of these columns to display the real-world elevation of 113 foot 4 and a 16th. To do that, I simply input that value into the datum level with the minus sign in front of it. The lower elevation now displays the proper real-world elevation, and all of the other elevations in this view will now be referenced from that value. It's much easier and better to lower your model closer to 0 and use the datum level to adjust your elevations on the drawings, rather than place your model hundreds or even thousands of feet above 0. While we're on the subject of drawing and level marks, I have another handy tip. It's really more of a technique, but tomato, tomato, I'll let you decide. Using the same example, I normally like to be a little more descriptive with the labels for the elevations, rather than just saying elevation. Ugh. Unfortunately, the level mark only permits a single line for the information and doesn't allow it to be stacked. And in most cases, the mark really gets a little too long. So what I do is create my own stacked elevation mark using the level mark and a piece of lettered text. To start, I create a text entity and describe the elevation. Set the frame type to underline, the leader type to with leader line, the color to match my dimension line, and the arrow type to plain line. I snap to the dimension line, and with the ortho on, I can drag it straight out. Next, I create a level mark with a prefix of EL period, putting the space at the end, and ensure the text color, height, and font match the text you just put on. Then set the frame type to plain, the leader line to not an arrow, and the color to ghost. The arrow type doesn't really matter, but I set this to plain just for neatness. I snap to the same dimension line point as I did for the text, and then I can drag it around until it looks good. I'll do the same for the lower elevation. I sometimes use the level mark for assembly drawings too, but normally stick to the simpler single line version since those don't normally need to be as descriptive. I prefer to put more information on things like dimensions and elevations and even part callouts, especially when working on general arrangement drawings, since those are typically drawn to a smaller scale and deal with way more parts than the assembly drawing. That's going to wrap it up for this one. I hope you found it informative, and if you did, please give it a thumbs up. Leave comments and questions in the comment section below this video. Check out the rest of my channel for more videos like this. Please consider subscribing if you haven't done so already. And as always, thanks for watching, and I'll see you in the next one.